All right, so for section 5.5, this lesson is all going to be about isosceles triangles. Okay, so back in 5.1, we were classifying triangles by their side lengths and by their angle measures. And one of them that we talked about was an isosceles triangle. Now, an isosceles triangle is a triangle that is going to have exactly two congruent sides. Okay, so let's explore isosceles triangles a little bit. So let's open it up. So first up, in an isosceles triangle, we're going to have certain parts that we can label. Okay, and these parts are the legs, the base, the vertex angle, and the base angles. Okay, so having this isosceles triangle right here, triangle LMN, we know that because of the tick marks there, that means two of the sides are congruent, but not necessarily that third side. So we know that's going to be an isosceles triangle. So going through, we're going to name first what is the base. So the base of the isosceles triangle is going to be the side that isn't congruent. Okay, so the base is the one that isn't congruent, so that's going to be side MN. So next up is going to be the legs. Now the legs of my isosceles triangle will be the two sides of the triangle that are congruent, or the two that have the tick mark. So in this picture, my legs will be LM and LN. So base is the one that isn't congruent, but legs are the ones that are. Legs are congruent. They are the same. Next up, we have the vertex angle. Okay, so the vertex angle is going to be the angle that is across from my base. Seems weird. You think base angle should be across from the base, but actually my vertex angle is going to be the one that is across from my base. Meaning, if I take my base right here, and if I was just to draw a straight line, I'm going to eventually hit an angle. And the angle that I'm going to hit is going to be my vertex angle. So the vertex angle in this triangle will be L, angle L. It is across from my base. And then that leaves my base angles. So my base angles are named the base angles because they're the angles that are created from the base. Okay? So the base angles are also going to be my two angles that are opposite from my congruent sides. Okay? So angle M, it's opposite from one of the congruent sides, and angle N, it's opposite from one of the congruent sides. So angles N and M, they're both opposite from the congruent sides, and they are both created down here at the base. Okay, so that's going to make M and N my base angles. Okay, so now let's talk about a theorem that we talked about. So isosceles triangle theorem. So this basically says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so we already know that in an isosceles triangle that we have two sides that are congruent. Okay, so in this one we could say AB and AC. Okay, so we already know we have these two sides congruent. That makes it an isosceles triangle. So what this theorem tells me is that the angles that are opposite from these sides, so AC is opposite from angle B, and AB is opposite from angle C. So if these sides are opposite from if these congruent sides are opposite from these angles, then these angles are also congruent. And that's what this theorem right here tells me. If AB is congruent to AC, then angle B is congruent to angle C. And if we flipped it the other way, we could say the same thing. So if I have two angles in a triangle that are congruent, okay? So let's say, for example, let's say I draw a triangle real quick. Okay, so let's say in this triangle, maybe I have, let's call it maybe a 50-degree angle and a 50-degree angle. Okay, so if these two angles are the same, then that means that they are going to be opposite from sides that are the same. So if I've got a triangle that has two angles that are the same measure, then because of the isosceles triangle theorem, that triangle will automatically be an isosceles triangle. So it works either way. If you have two sides that are congruent, then the angles opposite them are congruent. Or if you have two angles that are congruent, then the sides opposite them must be congruent. Okay, let's look a little bit deeper now. So we got a few examples we're going to work through. All right, so up here in the top left, if AC is congruent to AD, name the two congruent angles. Okay, so in this, we're looking at AC and AD. Okay, so that's this line and this line. So Isosceles triangle theorem tells me that if two sides in a triangle are congruent, then the angles opposite those sides are congruent. Okay, so with this one, we have to keep in mind, what triangle are we talking about? Okay, because in this picture, I could have four triangles. I could have my big one, and then this one on the left, this one in the center, and this one on the right. So which triangle am I talking about? Well, if AC and AD are both sides of this triangle, I must be talking about this one in the center. So when I talk about the angles, I'm going to be talking about this angle, and this angle. Well, if these two sides are congruent, their angles that are opposite them are congruent. So AD is opposite from angle ACD. And then the line AC is opposite from the angle ADC. So my two congruent angles will be ACD and ADC. Okay. Now we go another direction. Let's say that angles ABC, so this far left angle, and angle AED, this far right angle. Let's say those are congruent. Well, if these two angles are congruent, what segments are congruent? So now let's look at the triangle I'm talking about now. Now I'm talking about my triangle as a whole. So my sides are AB, BE, and AE. So that's going to be my only option I can have. So angle B is going to be opposite from AE, and angle E is going to be opposite from side AB. So my two congruent segments will be AE and AB. So be careful on problems like this. Identify what triangle they're talking about. So with the first one, if two of the sides in the triangle were AC and AD, then that meant we had to be looking at this middle triangle. But with this one, since we were talking about these outside corner angles, then that means we were talking about my triangle as a whole. Okay, let's look at this one. The triangle ABD is isosceles, and triangle ACD is a right triangle. Okay, so we got two triangles. Triangle ABD right here. Now, normally I say never to assume, but in that triangle, I think it's pretty clear what the two sides that are going to be equal are, AB and BD. Okay, and then we're also told triangle ACD is the right triangle. So this is the whole thing. And again, I don't want you to ever assume something to be true, but if we're looking at angles A, C, and angles CDA, I think it's pretty clear this has got to be the right angle. Okay, so we're also told angle A has a degree of 31. So what is the degree measure of angle 3? Well, if I look at my small triangle, triangle ABD, and I know that angle A is 31, and I can also assume that angle A is across from one of my congruent sides. So angle A is across from that side, BD. Well, the other congruent side, AB, must be congruent from an angle that is congruent to 31. So that means angle BDA must be 31 degrees, according to the isosceles triangle theorem. So now, how do I figure out what angle 3 is? Well, I know that angle BDA plus angle BDC equals 90, because these two angles together will equal to be 90 degrees because they're a right angle. So I know one of them is 31. To figure out the other one, I'm going to subtract 31 from 90. So I'll get that angle 3, this one right here, is 59 degrees. Okay, let's look at this last example. So we are told that triangle DEF is equilateral, and knowing that, we need to find x, find the measure of angle 1 and the measure of angle 2. So again, in this picture, I've got three triangles I'm dealing with. My big one, this one right here on the left, and this one right here on the right. So I'm told triangle DEF, that's my big triangle, is equilateral. Now keep in mind, equilateral means all sides are equal. Isosceles is 2, equilateral is all. So I can put tick marks here, here, and here. Okay? So now from here, we got to figure some other things out. So another thing to note with equilateral triangles is that in equilateral triangles, all of the angles are going to be the same. They're all going to be 60 degrees. So at the moment, these are the only things that I'm given, but I can assume that 60 degrees right here, 60 degrees right here, and then this angle up top, which would be 6x degrees plus angle 2, which I can make that statement right here, 6x degrees plus angle 2 is equal to 60 degrees. Okay, so now from here, I'm going to try to break it down and try to solve for each one of my pieces one by one. So first up, how do I solve for x? Well, if I cover up this smaller triangle right here, I've got a triangle that has degree angle measures of 60 degrees, 9x degrees, and 6x degrees. So if I add these together, I can set them equal to 180 according to the triangle sum theorem, which tells me all angles in a triangle add up to be 180. So if I add 9x and 6x, I'll get 15x plus 60 will equal 180 right here. Subtract my 60, I get 15x is 120. And then divide by 15, I'll get that x is equal to 8. So I've solved for x. Next up, I want to now solve for angles 1 and 2. So let's go for angle 2 first. Well, I know that 6x plus angle 2 is a 60-degree angle because it's one of my big angles in my equilateral triangle. Well, if I plug in x into 6x, I'll get 48 degrees. So this 6x right here is just 48 degrees. So if I want to figure out what angle 2 is, I'm going to take 60, which is the whole angle, 6x plus angle 2, minus 48 and equal 12. So angle 2 right here will equal 12 degrees. And so now lastly, if I want to figure out what angle 1 is, well, if I look now at this smaller triangle. So in the smaller triangle, I've got 3 angle measures. I got angle 1 that I'm looking for, my 60-degree angle, and my 12-degree angle. So again, triangle sum theorem tells me that all of the angles inside a triangle have to add up to be 180. So I could take angle 1 plus 60 degrees plus 12 degrees, and that'll equal 180 degrees. Which, if I wanted to go through and I wanted to solve for angle 1, add these together, I'll get angle 1 plus 72 is equal to 180. And then subtract, and angle 1 would be 108. And you see down here that I did it a different way. So down here, I said that 9x plus angle 1 was equal to 180. Down here, that's what I said. And then if I plugged in x equals 8 into 9x, I would get 72. So then 72 plus angle 1 is equal to 180. And then subtract the 72 again, and I get angle 1 is 108. So 2 different ways that you could have gone about solving for angle 1. And so with that, that's going to conclude our lesson for 5.5.